So let's take a look at converting periodic numbers into fractions. And I'm going to do two quick examples, one fairly easy basic example and one a little bit tougher. So let's take the number 0.3 repeating. So this is basically the number 0.33333 and it goes on forever. Now, uh, some of you might already know that this is actually the fraction 1 over 3. But let's see how, if you didn't know that this fraction is 1/3, let's see how we can convert 0.3 periodic into the fraction 1/3. So the first thing you want to do is you want to say, okay, let our variable x be our repeating number, 0.3 repeating. Okay, so what we do is we assign some variable to this periodic number. And the next step we do is we multiply by 10 um, until we get the same repeating end after the decimal point. So if I multiplied x by 10, so 10 times x is the same thing as 0.3 repeating times 10, and that gives me 3.3 repeating, right? Because what happens is we have 0.33333, etc. What happens is the decimal point jumps over here by 1 when you multiply by 10. So that's great. And now if I look at x and 10x, um, x is 0.3 repeating, and 10x is 3.3 repeating. And if I take their difference, the difference of the two, then, well, 10x minus x is 9x. And that's the same thing as saying 3.3 repeating minus 0.3 repeating. And that's just 3.0, right? If I subtract the repeating part, then it goes away, and all I'm left with is the 3. So what I'm left here with is that 9x is equal to 3. So that means that x, if I divide both sides by 9, is equal to 3 over 9. And if I simplify this, if I reduce it, I divide the top and the bottom by 3, I get 1 over 3. X equals 1 over 3. But let's remember what x was equal to. X was equal to 0.3 repeating. And now x is equal to 1/3. So since x is the same variable on top and here on the bottom, then it must mean that 1/3 is equal to 0.3 repeating. Now, using the same method, let's do something a bit more complicated now. I'm going to say, okay, we have 0.23 repeating. So now it's not just one number repeating forever. It's 0.23 that's repeating. So what this looks like is 0.232323, etc. Now the first thing we do is we assign the variable x to that. So let x equals 0.232323. And then we multiply by 10. So 10x is equal to 2.323232. Now if I look at x and 10x and I align the decimal points together, then the 2 and the 3 line up like this. And if I try to subtract them from each other, it would not get rid of the repeating part. I would not get perfect cancellation. So what I need to do is multiply again by 10. So I have 10x times 10, and that's 100x. And that's the same thing as saying x times 100. That means the decimal point will bounce over twice, and that's 23.23233. Now if I take a look at my 100x and my x, I notice that the 2 and this 2 line up, this 3 and this 3 line up, and therefore all the other numbers afterwards also line up perfectly. So if I subtract them, the decimal part will vanish. So let's do that. Let's subtract 100x and x. So we're subtracting that. So we know that 100x is 23.23 repeating, and we know that x is equal to 0.23 repeating. So when I subtract here on the left-hand side, I get 99x, and on the right-hand side, what I get is 23.0. Dividing both sides by 99, I get x equals 23 over 99. Now, I cannot reduce this, but what I notice is that x is equal to 23 over 99, but x is also equal to 0.23 repeating. So what that means, what that must mean, is that 23 over 99 is the same thing as 0.23 repeating. So the trick here to get an infinite decimal expansion and turn that into a fraction is by assigning the variable x to the periodic number, multiplying by 10 until all the decimal parts line up perfectly, subtracting to cancel the repeating decimal part, and then dividing the number in front of your x on both sides to get x all by itself, and that will give you the fraction that is equivalent to the repeating to the periodic number.